Your restaurant is building a rectangular garden. The materials cost $9 per foot for the west and east facing walls and $3 per foot for the north and south facing walls. You are given a budget of $1,584 to complete the project. Part A, what are the dimensions of the walls that will maximize the area? And B, what is the largest area that you can enclose? We will solve this problem using the method of Lagrange multipliers. Let's first set up the given information using this rectangle on the right as the garden. Let's let the west and east facing walls have a length of x feet. And let's let the length of the north and south facing walls be equal to y feet. The cost of the west and east facing walls is $9 per foot. And the cost of the north and south facing walls is $3 per foot. Our goal here is to maximize the area. Notice the area of the rectangle is going to be x times y. So let's let the area A be equal to the function f of x comma y, which is equal to xy. And now let's set up our cost equation so we can set up the constraint in the form of g of x comma y equals 0. The cost C is equal to $9 times the length of the west and east facing walls. The length of the west and east facing walls would be x plus x, or 2x. And therefore the cost of the west and east facing walls would be $9 times 2x. And then we have plus the cost of the north and south facing walls is $3 per foot. The length of the north and south facing walls would be y plus y, or 2y, giving us 3 times 2y. And we have a total of $1,584 to spend, which should be the total cost. This gives us C is equal to 18x plus 6y equals 1,584. For the method of Lagrange multipliers, though, we want the constraint in the form of g of x comma y equals 0. So we take this equation and set one side equal to 0. Let's subtract 1,584 from both sides, which gives us g of x comma y equals 18x plus 6y minus 1,584. And now to use the method of Lagrange multipliers, we need to set up and solve the system of equations given here by the partial derivatives, as well as the constraint g of x comma y equals 0. So our first equation is going to be the partial of f with respect to x equals lambda times the partial g with respect to x. The partial of f with respect to x is equal to the derivative of xy with respect to x, treating y as a constant, which gives us 1 times y, or y, equals lambda times the partial of g with respect to x. To find this partial derivative, we differentiate 18x plus 6y minus 1,584 with respect to x, treating y as a constant, which gives us 18 plus 0 minus 0, or just 18. The second equation is the partial of f with respect to y equals lambda times the partial of g with respect to y. The partial of f with respect to y is equal to x times 1, or x. X equals lambda times, for the partial of g with respect to y, we have 0 plus 6 minus 0, or 6. And our third equation is g of x comma y equals 0, which is 18x plus 6y minus 1,584 equals 0. Notice our first equation is y equals 18 lambda, and the second equation is x equals 6 lambda. And now we'll determine the value of lambda by performing substitution for x and y in the third equation. So performing this substitution, we would have 18 times x, which is 6 lambda, plus 6 times y, which is 18 lambda. Let's go ahead and add 1,584 to both sides, giving us equals 1,584. 18 times 6 lambda is 108, and so is 6 times 18 lambda. 108 lambda plus 108 lambda is 216 lambda. To solve for lambda, we divide both sides by 216. Simplifying, we have lambda is equal to 1,584 divided by 216. We want the exact value, so we'll go ahead and click on this Convert to Fraction button on the right and use the value of 22 thirds. Now that we know lambda is 22/3, we can go back up and determine the value of x and y. X is equal to 6 times lambda, which we now know is 6 times 22/3. Simplifying before multiplying, 3 simplifies to 1, 6 simplifies to 2. 2 times 22 is equal to 44. And then for y, we have y equals 18 times lambda, which gives us 18 times 22/3. Again, simplifying before multiplying, there's 1, 3, and 3, and 6 3s and 18. 6 times 22 is equal to 132. So now we know the dimensions that will maximize the area. The east and west facing walls have a length of x, which is 44 feet. And the north and south facing walls have a length of y feet, which is 132 feet. For part B, to find the largest area, we need to evaluate the function f of x comma y, or the area formula, given the x and y values that we just found. So the max area is equal to x times y, which is 44 feet times 132 feet, which is equal to 5,808 square feet. I hope you found this helpful.